AI engineers kind of sit at that crossroads of data science and software engineering, but their focus is laser sharp, developing, implementing, and maintaining specific AI solutions, especially in complex areas like, say, natural language processing, NLP, or computer vision. They're really central to getting advanced AI models built, trained, and deployed to tackle tough, often cutting-edge, real-world problems. And they're always thinking about making these models robust, scalable, and capable of learning over time.
So how does their day-to-day differ from an ML engineer's? Is there much overlap?
There's definitely overlap, but AI engineers often grapple with even more complex or specialized kinds of data, maybe from Internet of Things devices or vast amounts of social media text, and they might use more sophisticated or newer algorithms. Think things like transformers, which are key for the large language models everyone's talking about, or intricate deep learning setups. They're building these advanced models for very specific, demanding tasks like sophisticated recommendation engines or highly accurate predictive systems. Data prep is still vital, but the pipelines might be even more complex, pulling from more diverse sources.
And collaboration must be key here too.
Absolutely essential. They're constantly working with cross-functional teams. Data scientists might provide the initial spark or model idea. Software developers help integrate the AI into actual products, and stakeholders ensure it aligns with business goals and user needs. That multidisciplinary view is really important.
What happens after an AI model goes live? Is their job done?
Not at all. Right, the machine learning engineers, or MLEs, think of them as the bridge. They take the theoretical models maybe from researchers or data scientists, and they make them work in the real world. What's really key here, I think, is that they handle the entire life cycle of an ML model, from the very beginning to the very end.
The whole life cycle. Wow. What does that actually involve, like day to day?
Well, it kicks off with getting the data ready. That means pre-processing, cleaning it up, organizing all that raw info, dealing with missing values, getting it into the right format, normalizing it. Then comes building the actual models, selecting algorithms, training them on the data, tuning them so they perform well. And a really big piece is testing and validation, making sure the model's accurate, reliable, using the right metrics like accuracy or precision, or maybe means squared error depending on the task, and fixing problems like overfitting, when it works on the test data but fails in the real world.
Okay, and once it's tested and ready,
yeah,
they actually put it to work.
Exactly. Deployment is a huge part of it. Integrating these models into the company's live systems, and that often means working really closely with software developers. But it doesn't stop there. They're constantly monitoring how the model's doing, retraining it with new data, and making sure it can scale up and run efficiently.
So it's not just building it, but keeping it alive and healthy, basically.
Precisely.
Yeah.